I want to merge my robotics and AI work with my international development work and figure out how to use robotics to help the half the world that lives on less than $5.50 a day.
Peter, coffee, tea, or something else? What fuels your
Oh,
mornings?
coffee by
Yeah?
far.
Straight.
Yeah. I make coffee at about like 4:30 a.m. and I put some in a thermos for my wife and I start my day.
4:30 a.m. That's the time that you wake up?
I'm an early riser.
Is that like natural for you, or do you like set an alarm?
That's a natural habit. I've just
Wow,
become accustomed to that. Ben Franklin, early to bed, early to rise.
love that. Okay. And when you were a kid, what did you think you'd grow up to be?
Um, you know, I didn't really have a career path in mind, but I had this vision of myself being an organic farmer in New Zealand in a straw bale house. That was
Really?
like the vision of where I wanted to end up in life, and maybe I'll still end up there, though I'm a terrible farmer. Um, but but maybe with the help of robots, I can get
I was
there.
just gonna say, yeah, that's what the robots are for. Where did that vision come from? Was this like,
I worked in a bookstore when I was a kid,
okay,
and there are all these sustainable building books from like the 60s and 70s that I would read. And it just got me into a path of how to make things sustainably.
thing? Okay. What's one technology that you can't live without?
Oh, I used to live in Haiti and I didn't have electricity a lot. And electricity is by far the technology that I need.
Wow,
Um,
that's
Everything
a
else
first.
stems from electricity.
Yeah, it's a good point. What were you doing out in Haiti?
I did international development for about a decade of my life.
Yeah,
So I did design for extreme affordability and I helped small businesses get started that made infrastructure projects that were repairable locally.
very cool. Wow, that's awesome. And if you could fast forward 10 years and see one impact that your work's made on the world, what would you want that to be?
So I'm actually thinking that in this next stage of my life, I want to merge my robotics and AI work with my international development work and figure out how to use robotics to help the half the world that lives on less than $5.50 a day, because most of the world is not being served by current economic models, current production models, manufacturing models. And I think robots and AI could change all that.
That is, yeah, that's awesome. I love that. Okay, I want to find out more. Welcome to Machine Minds, everyone. I'm your host, Greg Tarusian, founder of Samson Rose, your robotics talent search partner. And on today's episode, I'm joined by Peter Haas, roboticist and public speaker from Varick. Thanks for being on the show today, Peter.
Thanks for having me.
My pleasure. Let's jump into it. So, before we go into all of that awesome stuff that you gave us a high level of just there, I'd love to learn more about your journey into robotics and AI. You know, your careers included entrepreneurship, academia, research, etc. So, if you could walk us through some of that, that would be great.
Yeah. So I got bit by the robotics bug very early, or at least the hardware bug.
Mm,
I took a year off from college and I did a few things. I worked as a park ranger in Bandelier National Monument as a volunteer for the Student Conservation Association. I lived in Paris working on a novel that never got published, but hey, worked on a novel, and went to a hackers conference in the Netherlands. It was great. But the big thing, the bulk of the year, was working on a satellite mission called Gravity Probe B. That was NASA satellite mission that employed a lot of students.
mm,
And like early career people, and I was lucky enough to get a job there. And I worked on software, but there was a hardware component in that satellite that was really just amazing to me. And that was this gyroscope that was made out of quartz and then coated with a superconducting material. And the quartz spheres of that gyroscope were within like 40 atomic widths of round. Outside of a neutron star, they're the roundest thing that we know about. They went to NIST for like a model of roundness.
Wow.
And they were made by robots. And it was a grinding algorithm that got them to that degree of roundness. But it was an example of the type of thing that even back then, I mean, this was the 90s, that
Yeah.
robots could make that human craftsmanship can't even begin to get near. Um, and so I really gained a great appreciation for robotics. I kind of filed it away for a few years. I did some software work doing telecommunications and mobile data stuff, and then I started a nonprofit that worked in emerging markets doing hardware. So we did renewable energy systems, solar systems that you could top up with your cell phone, like kind of appropriate technology stuff. And with that, I actually got invited to go to the TED conference.
Mm.
I was at TED and I go out to the parking lot and the Google self-driving car is doing donuts in the parking lot or figure eights in the parking lot. It's just cruising along like 45 miles an hour in this parking lot, leaving rubber on the road. And I got to take a ride in it and I was blown away. I mean, admittedly, it had a $75,000 Velodyne LiDAR on the roof.
Yeah.
So it
The
wasn't
the
quite
early
ready.
iterations.
Wasn't quite ready for prime time. Wasn't quite a
Yeah.
Waymo. But it opened my eyes to this new world that was coming with robotics and AI. And I realized then I was like, I need to do a career shift. I need to get back into tech. I need to do this. So I end up finding a partner who was doing drone work.
Yeah.
And I ended up founding a drone company with him. And the rest kind of continued along a more traditional robotics path. I went in, I managed research at the Brown University Humanities Centered Robotics Initiative as associate director. I did another startup in food and beverage and CPG. And I did computer vision work for a consulting firm that was doing like market analysis. And then from there, I did a couple years managing the growth of the robotics ecosystem for the state of Massachusetts. And I've just recently left that because I'm moving on to a boat and I'm going to sail the Caribbean. And I am uh, going to start consulting in robotics and AI. And so that is what I've been working on the past couple of weeks, and that's where I'm going.
I did not know most of this. We've met several times in person, but I think you need to go back to write a book because Haiti, Paris, Netherlands, boat in the Caribbean, academia, drones, all of this stuff is just like really, really cool. Running research, and it's just a great story. So, you know, kudos to you. Sounds
Yeah,
great.
I will have to get to writing with some AI help. Um,
Yeah, there we
I'm not
go.
the fastest writer in the world, so
During this transition from software back into robotics and just along this journey, you obviously mentioned your partner, that you started this drone company, etc. Did you have any key mentors or influences along the way?
I really owe a lot to a few people in the appropriate technology space. So there's a woman at MIT, Dr. Amy Smith, and elder gentleman at Brown, Dr. Barrett Hazeltine, who were really instrumental in me figuring out how to make things that were physical products more affordable and to get me
Mm.
thinking about how to mass produce things and how to make bombs that could be both rugged and cheap.
Yeah.
Um, and so So I really owe them a great debt of gratitude. And then for the robotic stuff in general, I feel like I've worked a few times with the folks at Mass Robotics.
Hmm.
And I feel like all of them have been great inspirations. I mean, Tom and Joyce and um, no longer with Master Robotics, but with Cybernetics now, Fady, and I
Yep.
mean, just great crew, really inspirational people who are doing a lot of great work for the robotics ecosystem in the U.S.
Yeah. Yeah. Mass Robotics is definitely up there. They're an awesome organization. Um, so let's talk about your role now and your work, what you're going to be focusing on next. Can you share what you want to be doing or what you're going to be doing on this consulting capacity, how you're going to help companies and structure that?
Yeah, so I've got kind of a unique vision of the robotics landscape and a unique set of connections. So I've been working closely with the greater breadth of the Massachusetts robotics ecosystem, which is about 500 plus companies and 100 plus research labs. I'm exposed to all sorts of really cool tech that's being developed for different verticals. And my goal is to really help bridge those connections and bridge those gaps between companies that have problems and companies that are developing novel technologies to solve specific problem areas. And what I'm
Mm.
trying to do, because robotics touches on everything, I'm trying to restrict to kind of one client per vertical.
Okay.
So going with one undersea client, going with one textile robotics client, with one aerial robotics client, to make sure that I don't have any problems with intellectual property or uh, kind of bleed over of scope.
Yeah.
So I'm being very conscious of that, and I feel like there's a big opportunity for people who haven't entered robotics yet to get connected with resources that can help them incorporate robots into their workflows
Mm.
a lot easier. Like I went to a factory where they're looking at doing robotics. They're getting frustrated with integrators and like the vendor landscape, and they just hired some interns to who are ex First kids, by the way. Great program, First.
Right.
Really introduce a lot of people to robotics, and thank you, Dean Kamen, for setting that up.
Dean's
Um,
awesome. Yeah.
but but yeah, got some ex First kids who were in college at that point, and then brought them on as interns and had them make one cell, just automate one portion of the manufacturing process. And they gave them the skills in that process. They gave them the flexibility to make mistakes, but they gave them the skills in that process to actually go on to automate more than half a dozen other cells.
Mm.
And they ended up taking all the people who had been working in those cells and retraining them on other quality control and other types of jobs. And that investment in just like a few in-house roboticists fundamentally changed the output of this company, which is making medical devices. Um,
Interesting.
and I feel like everybody talks about kind of like the lights out manufacturing scenario and whatever, and like how robots are going to take all the jobs, but there's a big gap between where we are now and when that happens.
Mm.
And I feel like during this period there's a huge opportunity for robots to help with problems like skilled labor shortages and just deal with being able to get consistent quality out of very limited raw material supply chains,
Yeah. Yeah.
and be able to deal with things just far more efficiently and effectively.
Okay. Got it. Got it. So it now seems like the ideal scenario, trying to balance consulting work, outreach, education, speaking, everything like that. How do you see that working with your network and also the variety of work that you're going to be doing?
I mean, I've done some consulting before, and it works out pretty well. But I think the unique aspect of where I'm going right now is I'm doing this on a boat. So I'm
Mm,
actually intentionally dedicating more of my time to doing activities that would be considered leisure, like sailing,
yeah.
which is actually a very robust time-taking activity. um, and then spend less of my time trying to make money.
Okay.
Because frankly, I mean, I feel like I don't know. I'll give a story to illustrate. Um,
Please.
when when I was between doing tech stuff and international development, I traveled one way around the world.
Mhm.
And I spent some time in Southeast Asia. And I was in Angkor Wat. Have you ever been to Angkor Wat?
No, never.
It's an amazing place. It's these old temples over hundreds of kilometers. And like they're just it's sprawling. I mean, just so many temples. You have to take motorbikes between all the different temples. And I got to this one temple with very steep stairs. And I was out there and I was about to climb the stairs, and this tour bus pulls up. And these folks who were in their retirement came out of the tour bus, and a bunch of them took one look at the stairs, like had a conversation with their partner, shook their heads, took a picture, and went back in the tour bus. And I was like, you gotta live your life while you
Mhm.
can still live your life. Life is short, and it's too short to spend in a 9 to 5, like for decades at a time. So,
Yeah. Yeah. I love that. You got to see the world. Yeah, it's an interesting one because a lot of there's that perspective of do you really want to work all the years of your life where you are capable, where you have your wits about you and your body that can do what you needed to, which we all take for granted, right? Until you
exactly.
retire and then you go to beautiful places like this and it's like, I'm just too tired to get out today, or I can't climb the stairs or go to that altitude or ever see that view or all the things that you want to do. So,
Yep.
uh,
Yep. Exactly. So I am embracing life and going to sail.
love that. Good for you. Good for you. That's inspirational. Um, let's talk a bit about, again, you have this very unique lens in the robotics space, right? And in the ecosystem in Boston, which is obviously one of the major hubs for robotics in the world. What current developments excite you the most in the robotics space right now?
I am torn between two things. One, lightweight models not based on transformers
Mm.
that run on uh, very low resource equipment. There are a
Okay.
lot of old robots out there. There are a lot of like kind of established fleets that aren't getting serious CPU upgrades. And lightweight AI models are going to be really the key to unlocking the next levels of productivity with those robots. And so I'm really excited about this stuff that Liquid AI has been dropping recently. So they do liquid time constant network based models. They're basically they're using differential equations for weights. So they've got these kind of variable weights. It's not like just saying a weight with back propagation. So they're lighter weight to create. They don't require like 10 gazillion CP or GPUs in a data center. Like you're not using all of the power of Manhattan to run your data center to like train your model.
Yeah.
So it's really an exciting kind of development. I'm very excited about there are other people doing this too, like Opteron out of the UK.
Mm.
Um,
They do some really cool stuff.
they
Yeah.
do some really cool stuff too. Exactly. And it's all just realizing like transformers are great, back propagation's great, but we've got this whole slew of other techniques that
Yeah.
we've been ignoring for about like 6 years now. And I feel like there's a big opportunity to kind of mine those techniques the same way Jan LeCun went and like grabbed back propagation and started using it for the postal service. Like back in the day before we had GPUs. I feel like there's a great opportunity to grab older techniques and try to deploy them and see how they work with modern processing power and like see what happens if you take like neuroevolution of algorithms or you do like neuroethology or whatever. So
Yeah.
yeah, so I'm excited about that stuff. Other thing I'm like, really excited about is improved controls for teleop in virtual and
Mm.
mixed reality. So like improved interfaces for actually controlling robots. Like I went to a robotics summit and expo in Boston this past spring, and like there's a there's a guy driving a unitary around with stick, and it's just like, I mean, aren't
Yeah.
we beyond this now?
Yeah.
I mean, we have plenty of VR interfaces for controlling robots. Like the
Right.
X Prize Avatar competition really spread that, and we actually pioneered some of that stuff at Brown, or Eric Rosen primarily did. Yeah, I feel like that uh, that avenue of exploration is going to lead to a world where we have like these call centers for controlling robots, where you'll be able to get labor disassociated from geography.
Hmm.
Okay, so right now, labor is tied to geography. Like if you want to physically install
Physical labor. Yeah.
a light bulb,
Yeah.
um, like you need to be there. But pretty soon we'll be able to have the technology where as long as you have a high bandwidth connection and you've got a robot on site and it's got sufficient dexterous manipulation, you'll be able to do those complex skills that AI is not going to be able to do for a little while with a human driving the robot.
Yeah, that's super exciting. I mean, we see so much of that with like offshoring and nearshoring, right?
Yeah,
In other senses like call centers, support, research, whatever it is. But um, doing physical work is a huge unlock. It's going to be
yeah,
exciting.
yeah, and
Uh,
it's coming. It's coming. I mean,
Yeah,
everything I see in research is pointing towards a lot more robots. I mean,
yeah,
like when I started with robotics, I think Willow Garage put out like
mm,
60 or 70 PR2s. It was under 100, I'm pretty sure.
yeah.
Um, like Amazon is beyond 1 million AMRs now.
It's
Um,
crazy.
like Ty Brady will have the exact figure, but they just celebrated their 1 millionth in
Yeah,
Japan recently. All of those, by the way, are built in Massachusetts, or most of them are built in Massachusetts, mostly built in Massachusetts. So
love that.
Massachusetts is a great place to build robots. Just a little plug for the state of Massachusetts there. Um, but Yeah, but like we're going to be reaching a world where there are billions of robots.
Yeah,
And that is a world that is coming. And it's going to have serious societal and ethical implications. Everything from kind of life cycle of the robots and waste management to cybersecurity and hacking
hmm,
to just human robot interaction.
yeah, yeah. It's crazy, exciting time. So much
Yeah.
to come. On the first point that you were making, that you shared with what you're excited about, I saw your post a couple of weeks ago talking about what you were getting kind of excited about doing more with less, and
Yeah.
that competition and attraction, improved model fusion link that you shared as well. So yeah, I think that is it's. I don't want to say like polarizing or like going against the grain because, as you mentioned in your post as well, like data center construction is propping up a lot of stuff right now, and
Yeah.
even we saw the whole like pushback or boat being rocked, excuse the pun, with DeepSeek when they came out doing their stuff for like a fraction of the cost and stuff. It's just
Yeah.
like, yeah, it's a
I
very
I
interesting
I,
time.
I mean, I feel like we're gonna look back at the models being created by Anthropic or OpenAI or any of these big players that are doing these large foundation models as kind of the computer in a room era of AI, just like the early 1960s computers that took up an
They're
entire
huge.
room.
Yeah.
And then we got to the miniaturization, and now they fit, and you've got supercomputers in your pocket. And
Right.
I feel like we're going to reach just better and better algorithmic approaches where we're able to do more and more with less and less power, less and less resource constraint on smaller and smaller chips,
Right.
and be able to do your complex AI algorithm on, say, like the 2030 equivalent of an ESP32, like a $4
Mm.
computer.
It's coming. Didn't
It's
Apple
coming.
just like with their new phones, or I can't remember if it was their watch, something like that, release something where you got like on-prem or on product like AI as well that's separate? Was
Yeah,
that
yeah. I think there are a lot of people who are releasing the on-device
on
models
device? That's it.
now. Yeah. So like the liquid models that I was mentioning that were dropped, those can be embedded in Android or iPhone apps, so
Cool.
that they totally run on device. So if you want your private LLM to be able to talk with and not send your data back to uh, Anthropic or whoever,
Yeah,
you can run it on your device and it's just fine.
I got to look into that. That's very interesting. Um, where do you think that robotics and AI are making unexpected breakthroughs at the moment?
Um, I think that dexterous manipulation and especially sense of like touch and the ability to manipulate kind of non-standard rigid like soft objects, not rigid objects, soft body manipulation.
Yeah.
I think there's a lot of interesting stuff happening there. The other area that I'm excited about that's interesting is the whole waste reclamation. And this is more for the like societal impact. But the waste reclamation side of things, like R-Stream and like a few others that are like trying to like build out more circular economies using robots. That's very exciting to me because, like, I feel like there's going to be a point where we can get more localized manufacturing as a result of circular reuse of materials.
Mm,
And that's
yeah.
going to be enabled by robots.
Yeah.
It's a problem that's too hard for people.
Yeah. I hadn't ever thought of that. That's interesting. In your opinion, are there, or what challenges, should I say, are there being faced right now, like technical, ethical, societal?
Oh, cybersecurity is a huge challenge.
Yeah.
I mean, like, I feel like it was a while ago when I was at Brown, but when I was at Brown, there was a study done port scanning the or the internet for Ross run robots. Um, and we found a lot. I forget the exact number in the paper, but it was a lot. And we could actually there's a Wired article about this. we like took over somebody's Baxter with their permission, um, like remotely, just exposed on the internet. We found it turned out to be a lab setup Da Vinci, but we found a Da
Okay.
Vinci surgical robot, which like freaked us out at first.
Yeah, right.
'Cause
You
we're
don't
like,
want to find
whoa, you
that.
don't want to find that on the open internet,
Yeah.
exactly. So I mean, like robot, just like the early internet, robotics has largely uh, been worked on in these kind of research lab settings. And a lot of the projects you see being deployed into commercialization are kind of one step away from that research ancestry. And like, I feel like the cybersecurity concerns. I mean, cybersecurity is a mess right now. It's a very admittedly adversarial. I mean, of course it's adversarial, but it's a very risky landscape where the attackers have significant advantages over the defenders. And when you throw in the capability of the computer being hacked to move in the environment, to see things, to hear things, like it's just a bad situation. Um, so yeah, so I do think cybersecurity is a big thing that roboticists need to start paying attention to early. And
Yeah. Yeah. I was going to ask because it tends to be something people think about. It's not just like I'll give a roboticist and any robotic startups there a little leeway here because it's not just them that fall into this, but most people when they're building a product, whether it's software or hardware, they don't build with the intention of integrating security or thinking in a secure way at first. And it's normally retroactively, which is also very difficult to do if you've been doing it for a long time. And then all of a sudden you're like, hey, actually, we need to make this very secure. Um, do you think that's like a shift that needs to happen or education that needs
it's
to?
education. It's a shift that needs to happen from the design level. I mean,
Hmm.
like there's a great talk by Bunny Wang, who's a hardware hacker, about chip level exploits on like supply chain for sensitive applications, and it basically is demonstrated to me that like you need to control your whole cybersecurity stack. Like, I mean, there are the exploits on the whole or Intel management engine. Um, so the which sits at ring zero in your computer. So like even if you have a fully secured operating system, like unless you're dealing with that lower level UEFI and firmware stack, depending upon how your robot's running, you're not actually providing security for your robot. So it goes a lot deeper than most people pay attention to when they're just like running their patches and doing
Yeah.
X, Y, or Z, and they're relying on the vendor, the board to take care of security. But I mean, like, yeah, I feel like there's been a uh, big adversarial push to try to exploit lower and lower levels of the processing on the computer, to be able to install advanced persistent threats. And you don't want an advanced persistent threat on a $50,000 robot, like, or a $20,000 or a $10,000 robot. Like, I
Yeah.
mean, like it's like having an advanced persistent threat on a CNC machine. And some of these robots are going to be
Yeah.
unpatchable.
Right.
And you're gonna have to figure out how you can isolate the robot network from the general internet. And this is something that manufacturers deal with all the time. I spoke to a manufacturer who suffered a ransomware attack about a year ago. And I mean, it was serious impact on their business.
Yeah.
I won't reveal what they're manufacturing, but like they were lucky that they're able to like it hit their accounting system, not their actual production system. So
Yeah.
they're lucky they're able to actually continue. But yeah, like things like the Maersk worm are going to be really big in robotics. I don't know if the Maersk worm was a 2017, 2018 worm that went through the shipping giant Maersk. It was not Petya,
Mm,
and it shut
yeah.
down
I remember that. Yeah.
shipping
Yeah.
like worldwide in a few hours. So I feel like we're going to see more stuff like that. And with robots, that's super dangerous.
Oh boy. Don't want to think about that. Just
Sorry.
cautionary tale for anyone
Cautionary
listening who's
tale.
building.
Cautionary
Yeah.
tale. Yeah.
Think about your security early. Um, can we talk more about you? Because I know you mentioned, now going into consulting, you're going to have one client in each vertical, like spread them out there. But I'm curious for you to share more about like what use cases that you've actually worked on in terms of like automation, manufacturing, healthcare, etc.
Yeah, yeah. So, I mean, I worked when I was at Mass Tech with the Mass Robotics Accelerator program and got to work with all the accelerator companies that ran through that program. So, in addition to other work I've done, like I got to work with a wide range of different companies doing things from like AMRs to sign language robots to biomedical sample prep robots, to food and beverage distribution robots, which actually is very close to my heart because I did a venture in that earlier a few
Yeah.
years ago. But yeah, so I mean, I've touched on a lot of different sectors, and I feel like that's where I have a real advantage over a lot of roboticists in that, like, I can see how ideas from undersea robots might be influencing AMRs, and might be able to influence AMRs. I can see how ideas from dexterous manipulation of fabrics might help you deal with a warehouse stacking problem where you're stacking something flexible like dog food packs or something. So yeah, I definitely think that like having the diversity of exposure to different robotics problems has been extremely helpful in kind of formulating my vision of how these problems can be solved with today's technology.
Yeah. I remember the sign language robot. I think they won one of the pitch competitions. Was it Robo Business or Robotics Summit?
Yeah, yeah, Tatum
Yeah.
Robotics, which is a great Massachusetts robotics company, um, is doing sign language robot for deaf-blind users. So they're users that communicate entirely in sign language, and this is kind of like a keyboard and screen all in one. Like
Yeah.
it's a way for them to interact with the internet.
Wow. That is very cool.
Yeah, it's very cool.
Any success stories or failure lessons that you've learned that you can share?
Um, yeah, I mean, I think there are a couple that all revolve around the same thing, both success and failure. So like I'll give a failure lesson first, and then I'll give a success lesson. So the failure lesson was from the company that I was starting when I first got into robotics, which was Exact Sense. And we were making a LiDAR scanning drone. It's carrying 32 laser Velodyne, which at the time was a 30 plus $1,000 piece of equipment.
Wow.
Um, and then was using ROS on board for sensor fusion, with RTK GPS, which at the time was like $18,000. I mean, this thing was like, it was brutally, and the drone had to be huge because the Velodyne was
Yeah.
huge. So like, it was a brutally expensive piece of equipment,
Mm.
and it was out there scanning with lidar civil infrastructure. So
Okay.
that's the purpose, is to scan power lines or scan bridges or that sort of thing. And at the time we were working on it, uh, DJI was just starting to really like push out good camera drones at cheaper and cheaper price points. And really, like within, we end up not getting to market because we didn't have the capability, or we weren't able to raise money on the East Coast. So it was kind of a shame because we had some limited autonomy. And it was about the same time Skydio was starting up.
Okay.
And Skydio raised money and we did not, and we disappeared, and Skydio went on to be Skydio. But we had some limited autonomy on there, and it would have been great. But within a few years, DJI was coming out with folding drones that could do photogrammetry with 4K cameras, or even maybe not 4K cameras at the time. Maybe it was just like 1080p cameras or something. Um, but they're able to do photogrammetry that could produce a model that was just about as good as the LiDAR model.
Mm.
I mean, it wasn't as good as the LiDAR model, but it's good enough.
Yeah.
And it costs $2,000 and fit in the palm of your hand.
Yeah. How do you compare
And
that?
like, this is kind of where I feel the LLM players are right now. They're building the like $100 million AI equivalent of the expensive robot.
Mm.
And that cheap, like commodity robot, or cheap commodity AI, is just around the corner.
Yeah.
So that's one example, and that was a failure. But I learned from that this technology is moving very fast, and you really need to be looking several steps ahead of what the state of the art is,
Mm.
to be able to, by the time you deploy. And the other thing is you need to get to market fast with partners. So there was a company that I got the pleasure of working with at Mastech, called Simple Automation,
Yep.
that was doing warehouse robotics. Um, and they ended up scaling, taking no VC. So they did everything off of commercial partnerships,
Right.
where they basically were selling like larger robotics contracts, robot as a service, and able to get enough revenue to grow to 30 people in a year. Um, which, I mean, off of, I think the Master Box Accelerator program is giving $100,000. Off of $100,000, that's almost unheard of
Yeah. We just
in the
actually,
hardware space.
the episode hasn't come out yet, but we had Ayman from Simple on the show as well. And yeah,
Yeah,
it's about what they've done is awesome.
it's awesome. It's awesome.
Yeah.
And I mean, I think the lesson from that success to learn is that you need to have your commercial partners in place who are going to bankroll not necessarily the manufacturing and production of the robots, but bankroll the translation from TRL 6 or so to TRL 9.
Yeah.
And I think it's something that is getting easier and cheaper to do. But it's still hardware, and it's still hard, and it's still expensive. So yeah. And
Sure.
then for those out there, just little gold tidbit for the roboticists who are like, well, how do I do robot as a service? I can't pay for my robots. Like I need to have all this venture capital to get a robot fleet out there. They're great financing options.
Mhm.
Like I've talked to Kineo, I've talked to Camber Road, I've talked to a few others who will finance your robot as a service,
Yeah,
who will provide you the money to get your robots built, um, and be able to let you amortize that cost over several years.
yeah.
So
I know that SVB has a product as well right now that
yeah,
also offers that. It's I was actually talking to a couple of the guys from there last night at an event, and yeah, it's always interesting when people are looking at RAS or is it really venture debt and how they structure it and how it's better for the actual company. So yeah, there's a lot of options out there basically, and you
yeah,
just have to go and
exactly.
ask. Yeah,
And just on the question of is it RAS or is it venture debt? If they don't take ownership of the robot, it's venture debt.
yeah.
Like it's not RAS if they're not taking ownership of the robot. But
Great stuff. Well, look, I'm very conscious of the time because we need to wrap up soon.
yeah,
Unfortunately, I think there's so much more that we can talk about. So we might have to do another episode off your Starlink while you're in the Caribbean somewhere
sounds
soon.
good. Sounds good. I'd be
Yeah,
totally up for that.
yeah, that and we've never done one like that before, so that would be really great. And you might have to give us a little tour of the boat as well. Before you go, I'm curious if there's any advice, guidance, cautionary tales, anything like that that you can give to people that are either looking to get into the space, looking to do more public speaking, or even founders building in the space?
Yeah, I mean, I think for the people who are building, there has never been a better time to build. Yes, things are a little uncertain to scale.
Yeah,
Like, like tariffs make things uncertain. Like finding your contract manufacturer can be like a challenging problem and all that. But if you want to prototype, there's so much amazing stuff out there
mm,
to draw on that you can stand on the shoulders of giants and make amazing robots and make robots that like even in solving toy problems have direct applicability to real world problems. And that's my final bit of advice is solve a real problem for a real customer. Don't just make an abstract cool AI model or like cool little robot that does something.
yeah,
Like you can find plenty of people, especially with demographic shifts and labor shortages right now, um, who need robotics. And start with a simple problem. Like find one cell that needs automation. Find one like slot in a line that needs to be changed, and fix that. And then the last thing I'd add is for people who don't want to reinvent the wheel and don't want to like create their own brand new robot solving a brand new problem. Uh, there's a huge demand for integrators. They're just like if you just graduated with a robotics degree and you can't get a job because you need to have like 7 years of experience and a PhD and whatever, um, but you did first and you can build robots and you can set up robots and you can program them, throw out a shingle and do integration for these manufacturers. There's
yeah.
so many mom and pop manufacturers out there that need cells automated because they literally cannot find the people to fill those jobs. And like the people they have, like the machinist who's been running that CNC machine for the past 30 years is getting close to retirement.
Right.
And like so I mean like I went to the Universal Robots ARM Integrator Conference where they had all their integrators come in showing their different solutions. And they were from all over the country, but the Northeast didn't have a single one. Like
Really?
I'm in the Northeast. There's nobody from New York or New England.
Wow.
The
That's
closest
surprising.
one was from Pennsylvania. And then they
Interesting.
had Colorado and they had Texas and they had like if it was North or South Carolina, like they had different places. But like there are definitely openings. And
Yeah.
if you need to find manufacturers to work with, last little tidbit of advice, go to your local MEP, your manufacturing extension program, and they will know who the manufacturers in your state are.
Awesome. That's great advice. Great advice. And I think it's something that
Cool.
a lot of grads are dealing with right now. And they're like setting their sights very high on roles or dropping it down and just being like, I'll take an internship. But there's so many opportunities to get that experience and be useful and be helpful and have an impact in the space. So that's great advice.
Yep.
Um,
Glad to
well,
help.
look, Peter, I really appreciate your time and insights. So thank you again for being on the show. How can our listeners learn more about you or connect and follow along?
Yeah. I'm at peterhaas.co, no com. And I'm also at veric.com.
Awesome. Well, we'll link all of those in the show notes.
Cool.
And we need to probably schedule something for while you are on your voyage, but I will speak
Sounds
to you
good.
soon.
Take care.
Thank
Thank you
you.
so much. You have a good day.
You too.
Bye.